Hi, I'm Sia and welcome to this week's market story. Today we are covering India's battery material movement and the bigger opportunity behind the EV boom. The EV story is usually told through car makers, battery manufacturers and charging networks. But the deeper opportunity may sit further upstream in the chemicals and materials that make batteries work. As EVs, grid storage and data centers and renewable energy systems scale up, the demand for these components is becoming strategically important. They are emerging as critical infrastructure for an increasingly electrified economy. China currently dominates much of the global battery material supply chain, from lithium refining and cathodes to electrolytes and battery cells. However, geopolitics is changing procurement priorities. The US and Europe are pushing companies to diversify supply chains, while regulations such as Foreign Entity of Concern regulations are making non-Chinese sourcing more valuable. For Indian manufacturers, this creates an opportunity that is much larger than domestic EV demand alone. The real question is how much of the global battery material supply chain India can capture. At a broad level, every battery has four critical components: the cathode, anode, separator and electrolyte. Each performs a different function, which is why companies participating in battery material ecosystem are targeting very different opportunities. The cathode is the energy storing side of the battery and is typically the most expensive component. It plays a major role in determining energy density, battery and overall cost. Common chemistries include LFP, NMC and NCA. In India, Gujarat Fluorochemicals is developing LFP cathode materials as part of its integrated battery platform. Himadri Specialty has also outlined ambition in cathode active materials, although its current positioning is stronger in carbon and anode materials. The anode is usually made from graphite and stores lithium ions during charging before releasing them during discharge. Its quality influences charging performance, battery efficiency and cycle life. Himadri Specialty is building its presence through synthetic graphite and anode materials, while GFCL EV is also developing anode materials. Another adjacent player is PCBL, which is working on conductive carbon materials, acetylene black and nanosilicon technologies used to improve battery conductivity and performance. Separator is a thin membrane placed between the cathode and anode. It prevents two electrodes from coming into direct contact while still allowing lithium ions to pass through. Although it represents a relatively small portion of battery cost, failure of separator can lead to short circuits and major safety issues. The electrolyte acts as a transportation medium for lithium ions between the cathode and anode. It typically consists of a lithium salt, solvents and specialized additives. LiPF6 is one of the most important lithium salts used in conventional lithium-ion electrolytes. Small changes in formulation can materially affect charging speed, battery life, safety and temperature performance. This is where Neogen Chemicals is making its largest bet. Through Neogen Ionics, it is developing electrolytes, lithium salts and additives supported by technology partnerships with MU Ionic Solutions and Morita. GFCL EV is also present in both LiPF6 and electrolytes, making it one of the most integrated competitors in this segment. Within the higher value additive layer, Tattva Chintan is targeting electrolyte salts and specialty battery additives, while Acutaas Chemicals is working on additives such as VC and FEC. These chemicals are used in relatively smaller quantities but can have a disproportionate impact on battery life, fast charging and safety. One of the biggest mistakes in emerging industries is assuming that announced capacity automatically translates into revenue. Building a battery material plant is difficult, but filling that capacity consistently is even harder. Battery manufacturers require consistent purity, reliability, safety and performance. This makes customer qualification critical. For companies investing aggressively today, the key question is not how much capacity they are building, but how quickly can they qualify customers and ramp up the utilization. Neogen provides a useful example. One Indian gigafactory is already sourcing commercial quantities of electrolyte from the company, with Neogen currently acting as the sole supplier. The customer's capacity is expected to expand from around 1 gigawatt per hour to 5 gigawatt hours over time. Another customer has completed qualification, while additional players are evaluating Neogen's product against Chinese alternatives. India's battery material opportunity may eventually become much larger than domestic EV adoption. The US is increasingly trying to build battery supply chains that reduce dependence on Chinese-controlled inputs, creating opportunities for qualified non-Chinese suppliers. Neogen has already seen multiple US electrolyte manufacturers conduct site audits, while additional international customers have provided provisional approvals. The significance of this shift goes beyond volumes. Global qualification would demonstrate that Indian manufacturers can compete on purity, process consistency, and reliability, not merely on cost. That is ultimately what can move India from being a domestic battery supplier to becoming a part of the global battery ecosystem. And that's it for this week's video. Thanks for watching. Don't forget to subscribe to PSB's YouTube channel.